For AlCl₃, this is another one of our sort of octet rule exceptions. This is an electron deficient molecule. Group 2 and group 3 elements only have 2 and 3 valence electrons, and so in general they sort of run out of electrons before they can make 4 bonds. In general, it's going to be best to draw Lewis structures that don't get to a full octet. So we'll see what that looks like. For AlCl₃, Al brings 3 valence electrons, each Cl brings 7, so we have 24 total. Our skeleton gives us this type of structure, which uses 6, which leaves us with 18 left. Then I can go in and fill in my lone pairs on each of the chlorines, 6, 12, 18 electrons. So that then gets me down to no electrons left. Now I go back to the aluminum. Normally I would need to get aluminum to an octet, and so normally I would say, okay, well, I'll take my chlorine, I'll take a lone pair from chlorine, and turn that into a double bond here. And that will get my aluminum to a complete octet. There's nothing wrong with this Lewis structure, but just based on where aluminum is on the periodic table, it does have a tendency to have that octet rule exception. If we look at the formal charge, this is bad from a formal charge perspective. Aluminum brought 3 and now has 4, so we have a negative formal charge on an atom that's actually not very electronegative at all. Chlorine here is very electronegative and has a positive formal charge, which is sort of bad. So again, according to this rule here, we'll say, okay, it makes sense because these are electron deficient compounds to just leave aluminum with 6 electrons. We'll remove that double bond and go back to full lone pair, 6 electrons around the chlorine. Again, doesn't really affect things too much, but that is in general considered the best Lewis structure for these types of atoms that have beryllium, boron, and aluminum. Again, then when I go back and look at this on the central atom, I only have 2, 4, 6 electrons around the central atom.